Alright, in this video, everyone, we're going to continue learning about dimensional analysis and how to solve these problems. And these are going to continue to be just one-step dimensional analysis problems. So at this point, we've learned two equalities. We've learned Avogadro's number, which states that 1 mole is equal to 6.02 times 10 to the 23 particles, which, remember, the word particles can be traded out for the word atoms or formula units or molecules. It just kind of depends on what you're talking about. Remember, atoms are used when we're talking about just single elements. Formula units are used for ionic compounds, and molecules are used for covalent compounds. And we've also learned how to calculate molar mass. And so we know that 1 mole is equal to the molar mass in grams of whatever element you have. And so depending on which of these units of measurement you see, that will tell you which equality you need to use. So those words are kind of your look for, or what you use to indicate what you need. So whenever we set up a problem, remember, we're going to read the problem and we're going to write down what's given to us and what we are trying to find. So in example number 1, it says how many grams of H2O, or water, are in 3 moles of water. So we write down, okay, what is given to us and what are we trying to find. So our given is always our number. So we have 3 moles of water. And what we're trying to find, it says how many grams of water. So we're trying to find grams of water. Now, the words we're looking for are either particles, atoms, formula units, molecules, or grams. And we find grams right here. And so because we have grams, that tells us that we need the molar mass of water. Now, over here, it's just says moles. That's not one of the words we're looking for, so we don't have to do anything because that is in both of our conversion factors. And we see that our chemical is water in both cases. So again, we don't have to do anything. So the only conversion factor we're going to need is our molar mass. Now, in order to find the molar mass of water, we're going to need to use our periodic table. So we know that we have, in water, we have hydrogen and we have oxygen. There are 2 hydrogens and 1 oxygen indicated by their subscripts. And we pull the mass of each element from the periodic table. So hydrogen has a mass of 1.01 and oxygen has a mass of 16. So when we multiply that out, 2 times 1.01 is 2.02 and oxygen is 16, but because they're combined in water, we combine their masses here and we get 18.02 grams per mole. So that means as a conversion factor, it can be written as 18.02 grams of water over 1 mole of water, or it could be flipped, right? It just kind of depends on how our problem is set up and what we need. So when we set up our t-chart, our given always goes in our chart first. So we have 3 moles of H2O, and we know that if moles of H2O is in the numerator, that means it also has to appear in the denominator. And so what we see is that moles of H2O is in the denominator in the original way that we wrote our conversion factor, so that's exactly how we're going to write it here. So we have 18.02 grams of water in the numerator. And what we see is that moles of water will cancel out with moles of water. Grams of water matches what we're trying to find. So we're happy about that, and we can put it in our calculator. So we multiply by the number that's in the numerator and divide by the denominator. So in our calculator, this would be 3 times 18.02 divided by 1, which gives us 54.06. And our rule of thumb in the regular chemistry class is just we're going to keep 2 numbers after the decimal. So it's 54.06 grams of water as our final answer. So we're going to follow these same general steps every time. Write down what's given, what are we trying to find, we write down what conversion factor we need, and we set up our problem. Let's look at example number 2. So example number 2 says how many moles of ammonium sulfate are in a sample that has a mass of 500 grams. So again, we're going to write down what's given to us and what we are trying to find. So we can see that we have 500 grams of something. Now, it doesn't say specifically which chemical, and since it doesn't, we're going to assume that it's the same chemical. So ammonium sulfate. Oh, and there is a typo. There should be a 2 there. So 2SO4, and that really changes things because that will change our molar mass. And we are trying to find, it says how many moles. So we're trying to find the moles of ammonium sulfate. So we put a 2 in parentheses, SO4. So again, we're looking for our key indicators. Since we have grams, this tells us that we need the molar mass. We have moles over here. That doesn't tell us anything because it's in both of our conversion factors, and we have ammonium sulfate in both, so we don't have to do anything there. So what we need to do is actually calculate, okay, what is our molar mass? Now, since I have that typo in this video, which I will change when I actually print out the worksheet, I'll go ahead and change it for those of you who are accessing this after I record this video. But for now, that tells us that we have nitrogen, hydrogen, sulfur, and oxygen. Nitrogen, remember, the 2 gets distributed to the nitrogen and the hydrogen inside the parentheses. So I have 2 nitrogens, 8 hydrogens, 1 sulfur, and 4 oxygens. And we're going to multiply each of them by their mass from the periodic table. Nitrogen has a mass of 14.01, hydrogen is 1.01, sulfur is 32.07, and oxygen is 16.00. So when we multiply across, we're going to get 28.02, 8.08, 32.07, and 48.00. And we combine them all together, and we get 116.17 grams per mole as our molar mass. Now remember, this can be written as a conversion factor or a fraction as 116.17 grams of ammonium sulfate. And yes, even though it's annoying, you have to write out all those letters, over 1 mole of ammonium sulfate. Or you can flip it. It just kind of depends on, again, how we have to set up our problem. So when we put in our T-chart, our given goes in the chart first. So we have 500 grams of ammonium sulfate. And then we know that because I have grams of ammonium sulfate in the numerator, then I also have to have grams of ammonium sulfate in the denominator. Now, when I look at my conversion factor, grams of ammonium sulfate is in the numerator, which means I'm going to need to flip it in order to put it in my chart correctly. So I'm going to have 116.17 grams of ammonium sulfate in the denominator, and my 1 mole of ammonium sulfate, and I forgot the 2 again, in the numerator. So we see here that allows grams of ammonium sulfate to cancel out. Moles of ammonium sulfate matches what I'm trying to find. So it means we can put this in our calculator. So we have 500 times 1 divided by 116.17, because remember, we multiply by what's in the numerator, divide by what's in the denominator. And so when we put this in our calculator, remember we always put the number we're given first, and we should get 4.30 moles, because moles is the remaining unit, moles of ammonium sulfate as our final answer. So you should be able to use these examples to help you calculate these practice problems. But notice, these examples were just using molar mass because in our previous lesson, we learned about using Avogadro's number. So each time you're going to need to check, do I need Avogadro's number or do I need molar mass? Which one do I need? Because you'll notice that some of these talk about grams, mass, and moles, but some of them talk about molecules or atoms, which would mean Avogadro's number. So please pay attention to your units. You're going to have to decide which conversion factor you need for all of these, and you have 2 challenge problems at the end.